Two lines rise, tall and grand, a vessel they form by nature's hand. Between their heights, the water slips, a secret of logic, the answer it keeps. We are given an array of integers called height. Each element represents the height of a vertical line drawn on the x-axis. Two of these lines and the x-axis form a container. Our task is to find the maximum water this container can store. Remember, the container must stand upright. It cannot be tilted. Let's take height equals to 1, 8, 6, 2, 5, 4, 8, 3 and 7. The maximum area is achieved between the line at index 1 and the line at index 8. The height of the water is limited by the shorter line, which is 7. The width between them is 7. Thus the maximum area is 7 times 7, which equals 49. For height 1 and 1, there are only two lines. The minimum of the heights is 1 and the width between them is also 1. So the maximum water area is simply 1. The brute force method tries every pair of lines. For each pair, we calculate the area as the minimum of the two heights multiplied by the distance between them. We update the maximum as we go. Although simple, this method takes n squared time, which is too slow for large arrays. A smarter way is the two-pointer technique. We place one pointer at the left end and the other at the right end. We calculate the area, update the maximum, and then move the pointer at a shorter line inward. This way, we systematically search for a better height while reducing the width. Why does this work? Because the shorter line limits the area. Moving the taller line inward only decreases the width without improving the limiting height. But moving the shorter line gives a chance to find a taller one and possibly increase the area. We initialize maximum area as 0 and left and right pointers at the ends. While left is less than right, we calculate the area, update the maximum, and then move the pointer pointing to the shorter line. At the end, we return the maximum area found. Here's the C++ solution. We follow the same two-pointer logic. Start with left and right pointers, compute the area, update the maximum, and move the pointer of the shorter line. Finally, return the maximum area stored. This algorithm is very efficient. The brute force took big O of n squared, but with two pointers, each pointer moves at most n times. So the total time complexity is big O of n, and space complexity is constant since we use only a few variables. To summarize, this problem is about maximizing the area formed between two vertical lines. The brute force method is easy but slow. The two-pointer method is fast and elegant. The key intuition is that only moving the shorter line inward can potentially improve the result. Thank you for your attention.